Hello everyone, I am Aditya Kumar Sharma and today I'll be demonstrating my end-to-end Azure Data Engineering pipeline built on the Brazilian Olist e-commerce dataset. The goal of this project is to automatically ingest new data, process it through the Medallion architecture using Azure Databricks and Data Lake, and finally deliver business-ready dashboards in Power BI. Let's begin with the overall architecture. Here we can see the architecture. Our pipeline starts when CSV files arrive in Azure Data Lake Storage. Then a storage event trigger immediately notifies Azure Data Factory, which orchestrates the complete workflow. Data is processed through the bronze, silver, and gold layers inside Azure Databricks, which all uses Apache Spark. The final analytical table are registered in Unity Catalog, exposed through Databricks SQL Warehouse, and consumed by Power BI for business insights by the user. Everything here runs automatically without manual intervention, and it can run on its own. The dataset I used is Brazilian e-commerce public dataset by Olist. This project especially uses this because it has over 100,000 e-commerce orders spread across multiple business entities like orders, customers, products, payments, and reviews. Since the data is normalized across several tables, it closely resembles real enterprise ERP systems and is ideal for demonstrating modern data engineering practices. This is the data that I downloaded from the Kaggle. Here we can see my storage account and the block containers in it. I made two block containers, input data and output data. So we'll go into input data. And in here, let's see our pipeline in action. We will ingest our file. So I have a file for this upload. Here I'm uploading an incremental orders CSV file into the landing zone inside Azure Data Lake Storage. In a production environment like this file would typically arrive from ERP system or an API. As soon as the upload finishes, the storage event trigger detects the new file and automatically starts our Azure Data Factory pipeline. Notice that I never manually started the pipeline. Here we can see the trigger started. Inside ADF, we can see our pipeline has started successfully. Bronze, silver, and gold are three sequential stages here. Each stage begins only after the previous one completes successfully, ensuring reliable data movement. Let's go into the notebooks. Here, the bronze notebook ingests the raw CSV files and stores them as delta tables. No business transformations are applied here. This layer preserves the original source data exactly as it's typed, providing a reliable historical record for editing and future reprocessing. Next, we'll move on to silver layer. Here I remove duplicate records, validate mandatory fields, and standardize data types and handle the missing values. Instead of reprocessing the complete dataset every time, I use Delta Lake Merge for incremental loading. Existing records are updated while new records are inserted, making the pipeline efficient and scalable. You can see here it's used as upsert functionality. The last of the notebooks is gold. Multiple data sets such as orders, customers, products, and payments are joined together to generate business-ready analytical marks here. Here, we can see that these optimized tables are designed specifically for reporting and decision making. Further, once the gold table is created, they are registered into Unity Catalog. This provides centralized governance while exposing clean business tables through Databricks SQL Warehouse, which serves as SQL endpoint used by the Power BI. Here we can see. Here we can see the SQL warehouse, and also we can see the query. Here we can observe this has that. While we explored the notebooks, the pipeline has completed successfully. All bronze, silver, and gold activities finished without errors, confirming that the complete workflow executed automatically. Now we can see that in output data, such folders are made, bronze, gold, and silver. Now we can see our Power BI dashboard. This overview page summarizes key KPIs, including revenue, orders, customers, and average order value. And we can see here by the parameters of monthly and state locations of the customers. Second page of this is products page that analyzes performance and payment behavior of the customers. We can use this to see the behavior and know which categories are the most revenue generating. The third is the operations page that mainly focuses on the setup performance and delivery timelines and delayed orders. Like we can see here. To summarize, this project demonstrates a complete modern Azure data engineering workflow. It combines event-driven ingestion, Medallion architecture, Data Lake incremental processing, Unity catalog governance, SQL warehouse, and interactive Power BI dashboards into a scalable production-style solution. Thank you. That's my project.